Hello to everyone. For today, we will continue with our lesson, and specifically, we will be having a special rule on proving arguments for this lesson, and this is called the conditional proof. And under this, we would still be using our rules of replacement, our rules of inference, but we will be looking at a special case. And for the conditional proof, this will work when the conclusion given is a conditional statement. So when we say conditional statement, it must be an if-then clause. So for example, we have the conclusion P implies Q. And of course, we have here our premise or premises, as the case may be. So just take note of the term. We're looking at the conditional proof. Therefore, our conclusion is a conditional statement. And when our conclusion is a conditional statement, the conditional proof states that from the original argument, we have our premises, we have our conclusion, we now break down our conclusion. So looking at this argument, what we will do is we copy the if clause, okay? And this if clause will now be treated as a new premise, and then we take the then clause as our new conclusion. So this will only happen when we are having a conditional statement in the conclusion. We take the if clause, we make that as a new premise, and then the then clause, we make it as a conclusion. Therefore, when we will now work with our new argument, we have our original premises plus the new premise coming from the if clause of our conclusion, and then the new conclusion will now be the then part of our new or of our original conclusion. Let's take an example for you to see this better. Example number 1. We have the first premise as A or B implies C and D, then followed by a second premise, D or E implies F, and then we have the conclusion A implies F. Clearly, we can apply here the conditional proof. Why? Because our conclusion is a conditional statement. And according to the rule, what we do is we copy the original if clause, make that as a new premise, and then the then of our conclusion becomes our new conclusion. So what is our reasoning here? We will use the conditional proof. Okay, so that will be our first step. Since the conclusion is a conditional statement, using the conditional proof, we get the if clause as a new premise, and then the then clause becomes our new conclusion. Okay? So next, so that's now our new conclusion, F. This is what we want to come up with based from our premises. What can we do? Again, looking at our statements. Looking at our premises, we have here a conditional statement. We have here a conditional statement. And where do we find F as the conclusion? F is in the second premise. So our target is we need to produce a D or E since this is an implication, so that we can use modus ponens, so that we will just be left with F. So it also means that we need to get rid of A, B, C, D. And how do we do that? Okay, this is an implication. If this is again an implication, we can produce an A or B. So we can use again modus ponens, or we can use a C and D. So we can use the modus tollens. Of course, we must have the negation of that. So we can use the modus tollens. But what do we have as our new premise? We have A as our new premise. Since we want to get rid of A or B, and we already have here A, what we can do is we can first what? Add B to A. Since A is existing, we can have A or B, and this is what? Using addition. Addition based from line number 3. And then, since we have already produced A or B, using 1 and 4, we have the structure of modus ponens. This is an implies. We have the first proposition present. Therefore, our conclusion is C and D using modus ponens of line number 1 and line number 4. Next. So we have C and D. Remember, we want to produce a D or E, so we can get rid of D or E using modus ponens, and we're left with F. But what we have here is C and D. So we don't need C, but this is a conjunction, so we can just retain D. And what rule is that? We can use simplification. Simplification of line number 5. And after simplifying line number 5, we have already D. This is OR. Therefore, we can use addition again. D or E addition based from line number 6. And since we have D or E using modus ponens from line 2 and line 7, that leaves us F using modus ponens of line number 2 and line number 7. And with that, we now have derived the desired conclusion, which is F. So that's an example of an argument using the conditional proof. Again, one limitation of the conditional proof is you can only use this if the original conclusion given is a conditional statement. So the rule there is you can just break down your original conclusion, taking the if clause as a new premise and then the then clause as our new conclusion. Let me give a second example. Premise number 1. We have, let's say, A implies B implies C. Premise number 2. B implies C implies D. And then our conclusion is A implies B implies D. There you go. Observing our original argument, our original conclusion is a conditional statement. Therefore, since our conclusion is a conditional statement, we can break that down. We can get the if clause as a new premise, and then the then clause becomes our new conclusion. So this is using conditional proof. But before we proceed further, again, the new conclusion that we have here is a conditional statement. Since it's a conditional statement, we can again break that down using the conditional proof, making B as a new premise and then D as our new conclusion. This is again using our conditional proof. Therefore, D becomes our new conclusion. Let's go back to our argument. So our argument now has four premises. Premise 1 is A implies B implies C. Premise 2 is B implies C implies D. Premise number 3 is A. Premise number 4 is B. Now, we have an implication here. Therefore, if we combine 1 and 3, since we find A for both, we can use modus ponens. Let me just place the second half of the proof here so that we can see the lines. So combining 1 and 3 using modus ponens, that should now give us line 5. We have B implies C. Modus ponens of 1 and 3. Modus ponens of 1 and 3. Then, after using modus ponens of 1 and 3, what else do we observe here? What do we need again? D. Where do we find D? We find D from premise number 2. Okay. So what can we do next? Look at 2 and 4. Again, we find B common to 2 and 4. Therefore, that should give us C implies D. Modus ponens again using 2 and 4. That's right, because the proposition B is present here. And then, after using modus ponens for 1 and 3, 2 and 4, we have B implies C, C implies D. Looks familiar? C and C. How will we simplify that? We can use our hypothetical syllogism. P implies Q, Q implies R, therefore P implies R. So in this case, we have B implies D using hypothetical syllogism for 5 and 6. Okay, we're almost there, I think. Since we are after D as the conclusion, this is an implication. We have B here, we have, therefore we can use modus ponens again. Modus ponens for 7 and 4, that should give us the conclusion D. Modus ponens of line number 7 and line number 4, which now gives us the desired conclusion. Okay? Another example. we have premise number 1. A implies B and A implies C. And conclusion kagad, we have A implies B and C. Look again at your expression. We only have one premise and we have our conclusion, but our conclusion is a conditional statement. Since it's a conditional statement, we can get its if clause, make it as a new premise, and then we have the then clause becomes our new conclusion. This is again using conditional proof. So that's now our conclusion, B and C. What can we have now? So we have an added proposition here, A. So where can we use that? Look at our premise number 1. What can we do with premise number 1? Since this is an and, we can break this down into two propositions using simplification. So that should give us A implies B. Simplification of premise number 1. So similarly, we can use again simplification for premise number 1, taking the second part. That should be A implies C. Simplification again of 1. Then from there, what can we now do? Remember, our new conclusion is B and C. B and C, we find B and C in premise number 3 and premise number 4. But for both premises, we find conditional statements and A as their first propositions. And you will find in premise number 2, our proposition A. Thus, what can we use for 3 and 4? Isn't it for 3 and 4, we can use the modus ponens rule, and that should give us B. Modus ponens of 3 and 2. So we now have B. Our conclusion is B and C. Where do we find C? C is in proposition 4. It's an implication. If we can produce A, which is already in premise number 2, we can use modus ponens. That should give us C. Modus ponens of 4 and 2. Finally, our conclusion is B and C. We have B in premise 5. We have C in premise 6. Using conjunction, we have B and C. Conjunction of 5 and 6. And we now find here the desired conclusion, B and C. Okay? So there you have it. That's our short lesson for today. I'll be giving some examples for you to work on later on. Okay? So I'll just make this video lecture short so that at least it will be easier for you to absorb. I'll be giving you another video lecture tomorrow. It will be another special rule. Okay? So again, just go over the proof, the method that we have introduced here. Just take note of the special case. This is only applicable when the conclusion is a conditional statement. So if you have again questions, please feel free to email me, feel free to message me. So goodbye. I'll see you again in the next video lecture.